This is a talk that's been in the works for like 10 years in my head. I'm just kidding. So this is kind of this talk is going to be about I've been using, and I'm guessing pretty much anybody who's been working on. Oh, this is actually, I think this is streaming the wrong site or the wrong. Sorry about that. Let me restart my stream here. Okay, should be this one. It should be full screen, and it looks like it's working now. Okay, so yeah, this talk is kind of about. I'm pretty sure every developer is having the same experience as I am, in that we're using lots and lots of frameworks, whatever you might define that term as, and stuff is getting really, really disorganized, and so there's a lot of stuff to take into account and kind of look out for when working with all these different frameworks and building software on software, because obviously we have so many things built on each other, even to the point of an operating system is just built on a lot of stuff. So with that said, I'll kind of get into it here, and basically I'll start with, and bear with me here because obviously you know what a framework is, but I'll just kind of start with what I mean by the word framework in this talk. And for me, I kind of have three separate pieces of code, if you will, or pieces of software that are defined here. And I kind of refer to them all as framework in this talk. So what that is library, which is kind of just a collection of code or assets. It's not very intelligent. It kind of provides you with a lot of functions or just general data to use in whatever your actual solution or software stack is. So then going off of that, for me, a framework I define as kind of a more intelligent library which tends to manage things. You can think of something like React, where React will kind of take over your DOM, and so you're kind of using a system that utilizes a library underneath. So that's kind of what I mean by framework. And finally, kind of like the highest level one I seem to think of is an engine, which is kind of a development kit or a tool that helps you deploy software, and that's kind of built on a framework. And so it's kind of like this pyramid of like library, framework, engine. Where an engine is, you can think of something that's like a game engine, which I'll show in this example, like something like Unity or Unreal, which not only has that framework, but also lets you build. So, sorry. Yeah. Okay. Weird. Oh yeah, I'm seeing that. Yeah, I'm seeing that. Okay, let me go ahead and stream one window, or sorry, one screen here. So I'll just film screen 2, and let me know if that fixes it. Okay, awesome. So sorry about that. Okay, cool. So assuming that's all fine, I'll get started again. And so yeah, so basically an engine is kind of just built around that, helps you build, and has its own kind of system for deploying that. So okay. So again, another kind of basic concept here, but obviously I want to define like what the purpose of using a framework is, because this talk is kind of going to make it seem like it's negative, but of course we're going to use frameworks, and the reason that we use them is what I've kind of thought as two. You can kind of boil everything down to two purposes, which is either accelerating development and or avoiding technical debt. And if you're not familiar with the term technical debt, that just means creating a system that's more strong or sophisticated to the point where you won't have to go back and waste a lot of time fixing it when you want to build new things on it. And so I've kind of found that those are the two reasons that I'm using frameworks, and I think you can boil everything down to one of those 2 points. So with that said, if you're in a production environment, which is what I'm always going to be referring to, where you're kind of making a commercial app, because most people are making some sort of software, for a job, for another company, for their own company, or for a client, and so on. And usually it's for some profit. So with that said, if you're in that environment, you probably don't want to use the framework for the sake of improving that framework or further developing it. You probably don't want to use it for practicing when you're deciding on using it for like a commercial app. And you probably don't want to be using it in a way where you redefine your concept of what good software architecture is. And I say that because, which it might sound like not like kind of common sense to not think, oh, I'm going to redefine fundamentals here. But I think that it's easy to fall into the trap of doing that, either consciously or subconsciously. So just something I want to mention here. But with that said, it's obviously fine to use a framework for any of those purposes. But again, it's just in this commercial focus where I think you probably would want to avoid that. At least I would. Okay, so kind of the underlying problem here is, the whole point of this is, of course, we're going to use frameworks, but issues will arise when we do that to look out for. So, for example, certain aspects of the software that we're creating are now kind of limited because they're forced in a way to adhere to some sort of system that's been determined for us in that framework. And also, this is another like very common thing I see is we're more inclined to use familiar patterns that we see used in a certain framework, and kind of like copy paste that and build a new solution around that or based on it, rather than think about a problem and think, how am I going to solve this, and then determine what the solution is from there. So, for example, one example here is I think the most basic one is going to a tutorial for a framework, either in its documents page or, from anywhere, a third-party one, and then building a solution based off of that, either by copy-pasting or, just following the same pattern. And kind of finally, my last point here on what the problem is that we tend to compromise, like, the creativity and originality to base software on a framework, in that it's similar to the last problem. It's we tend to try to follow a pattern we think is right, rather than follow a pattern that creates some sort of the exact software that we want, or has a certain kind of development standard that we want inside of our piece of software. So, and I kind of say here, like, it's kind of like standing in line within the boundaries rather than being more of a maverick and figuring out what the proper solution is, or what a solution that you're comfortable with is. Okay, so I'm gonna go here with some examples of what I'm talking about are and how it might be limited or we might be compromising some things. So the first one I'll use here is what I actually use the most. So I use Unity for the most part, and there's a lot of limitations with Unity, but the purpose usually for Unity is, and of course this is an opinion, but it's a very common opinion that I agree with, is that if you're developing a game in Unity, you're often going to be done faster with the game than you would in, say, another engine like Unreal Engine. With that said, there are reasons for the two of them. But so with that said, Unity comes with a lot of these limitations and weird general software patterns in it. So for example, anything inside of so Unity is a game engine, and anything inside of one of the scenes of the game pretty much has to be a game object, as long as you're seeing it or it's interacting with the whole Unity engine, which can cause performance issues and forces you to follow their pattern. In the same way, a game object has components on it, which are your own custom software. So they're called scripts or mono behavior scripts. And on top of that, you have to attach these components to these game objects and follow that pattern. And on top of that, you have to inherit from this mono behavior class, but for Unity to run the mono behavior functions, it's not actually using inheritance, it's using reflection, which is, if you don't understand what that is, it's just strange, is what it is. And beyond that, the other limitations are it's a closed source editor, you have to use their tools, and you have to use their build options. So this is what I've been using a lot recently, is Material UI. This is a React library that is created with the purpose of following material design, which is essentially both a UI layout and style and a UX kind of system that's it's right, like it's a suggestion essentially, but it's like its own thing. And so there's a few things that I found strange is when you're using Material UI, you kind of have, if you use their highest level components you expect them, or they expect you to use, you'll have some weird things like having forced button sizes. A lot of these components are based off of these default material design decisions. If you want to use CSS, you kind of have a lot of these strange jumbled classes, so you tend to use their style system instead, which I'm fine with, of course, but if somebody wanted to use CSS, then it's kind of annoying generally, which we're seeing in the project we're working on, actually. And so it's, in my opinion, it's kind of a must to use like JSS, which is essentially CSS built into JavaScript objects. And going further than that, Material UI will favor that you use React props over JSS, and so you kind of have this system of use props, and if you can't, then use JSS, and if you can't, then use CSS. And it doesn't look pretty when you get to that point. Finally, the last one is, you've probably heard of Redux. This is the example of kind of reusing these patterns rather than thinking of your own patterns. And I'm very guilty of this myself, is with Redux, you don't, sometimes you don't really think, you kind of just default to the thought of stuff goes in the store. If you have data to pull from the web, it goes in the store, and then if you want to display it inside of an interface, you pull it directly from the store. Everything follows this monolithic object. And so to talk to the store, you have reducers, which essentially format the data to go into the store, and you have actions which will pass data into a reducer to send stuff to the store, ultimately. And you kind of see in every Redux project, if you open it, I guarantee you'll see an actions folder and like a constants folder and a reducers folder, and there's all this stuff that's copied and pasted, and you see kind of the same pattern everywhere. And, that's just something that I've been thinking about a lot. So... and we talk about this all the time because I'm kind of the Redux guy at work, and so everybody will always talk to me like, should I use Redux here? Should I use React here? Like React State? And when I talk to them about it, there's often a lot of like, I don't understand the purpose of Redux, and I very commonly keep hearing that again and again, and they don't. And there's kind of there's a reason that they get that feeling from Redux, but I don't want to go too far into that here. Okay, so I've already, I've explained why frameworks suck. No, I'm joking. I've explained some of the pitfalls of frameworks, and so I'll say there's kind of a real world problem here that I'll show you in my Unity project, and that's kind of basically those game objects I talked about inside of Unity. They communicate through each other in certain ways. One of them being collision detection, so two things hit each other and then they can talk to each other, but we can't be sure. With Unity's code and its software system, we can't really be sure what the thing we hit is until we've grabbed stuff from it. But you might not need to, is my current opinion, because if you use some techniques and you kind of follow the structure of polymorphism, you don't really need to do that a whole lot. You don't need to be sure what it is. And so the trap here is, if you want to communicate together, you have to use this function called getComponent. And the game objects are not typed, so they can have any sort of component. So when you use getComponent, you might get something null back. And so you can see here, basically, there's this if statement that is checking if the component that it received here, when it hit each other, when two things hit each other, it's checking to see if it exists or not. Because it's not a property of an object, it's something attached to a game object, which is this abstracted concept built around the object-oriented system. So it's a little bit weird in that way. in that sense, so now we don't know like what type of component we're using until we grab it, and this kind of throws away some object-oriented standards that I tend to follow personally, and I think a lot of other people do. And the reason that this is a problem is because I think if statements are quite a code smell. So yeah. So I've prepared a little video here that's just showing one example that uses the system that I've described. It uses get component, but it's in more of a certain way. So you have this ship over here shooting the player ship. The player ship then blows it up, and there's a lot of interaction between two actors here. Well, I guess two game objects, but I have a system here that turns them into actors. And here's kind of the literal code here. It's just, shooting a laser at this guy, and it does some stuff when it gets hit, basically, and eventually blows it up. So my solution for dealing with that gross kind of get component and if checks and all that is I've ensured that everything in my project's an actor. I have a few. I try to write get component calls as seldom as possible, and then I just override these subclass members for different kinds of actor behavior. And so if an actor component doesn't exist, then I have a try catch that just ensures that it does exist, and tells me to go fix it. So then around that, we kind of have these examples of overriding where when the two ships hit each other, these kind of automatically get called, and it's not too important to see exactly what's happening here, but basically when something's hit by like that laser tool, it just takes damage and so on. And then we have a system here that just it has this one get component here that has the try catch, and then it just adds the actor component on there if it doesn't. And again, it lets me know that I'm not supposed to do that. I should have made sure an actor was attached to that game object ahead of time. And so it's just called in Unity's collision enter 2D function. So here's just one more video that's kind of showing a lot of stuff going on with that system. So you'll see, again, I'm shooting that other ship, and there's just some stuff going on here, and it's not too important to like exactly say what's happening, but basically all this stuff together uses this system of a game object hits another game object, it ensures there's an actor on it, and then it just lets the actors handle what it wants to do. So if a human actor hits a traitor actor, it'll tell the traitor actor, hey, you got hit by a human actor, and it'll do whatever it wants to do based off of that. So that's everything. Hopefully it wasn't too both high level and low level. But the main concepts there were there's some stuff I'm doing to try to not lose my mind when using all these new frameworks, and hopefully you are too. So yeah, thank you for listening.